Welcome. In this video, I'm going to talk a little bit about how we choose a suitable method when we're presented with a simultaneous equation. So it can be a little bit daunting when you get something like this. Where do I start? Which method should I choose? How you choose your method depends on how the simultaneous equations have been written. So for instance, in this first one, we can see that y is the subject of both. Now, if you have y being the subject, or if you have x being the subject, so x or y just by itself on one side of the equals, then you should be using a substitution method. And so what that means is, in this case, you'll set these two equations equal to each other, or if you had x equal to something, then you could substitute that into the other equation. That's going to be the easiest method for you. Now, if we look along the next equation here, in this situation, you probably could choose either method. If you look along at the coefficients here, you have a 1 here, which means that this is going to be easy to use substitution, because to make this y the subject, I'm just going to pick up this 2x, move it onto the other side, and you'll have y is equal to 10 minus 2x. Once you have that, you'd go ahead and substitute it in here instead of y. That's probably the easiest thing to do. If you do have a preference for elimination, you still could, because if you look at this top equation here, we could multiply everything by 2, and then you would have matching coefficients here. So we'd have 2y and 2y, and then you could go ahead, and in this case, you would add those two equations to solve. So in this case, either method could work for you. I'd probably recommend the substitution whenever you see that one of the coefficients is 1. However, this is also easy to scale up this equation if you prefer elimination. Then again, in the next problem, so your first step is to look at the coefficients here. And so again, in this case, you can see that we actually have matching coefficients in the 3x. So elimination is going to be very easy. I could subtract these equations and these 3x's will cancel. However, as you also see, we actually do have a 1 here and a 1 here, which means if you prefer elimination, then what you could do is rearrange this top equation, take the 3x onto the other side, then you would have y is equal to something, and you would substitute that in here instead of y. So again, for this problem, either method is going to work. Now looking down at the next one, again, we start off by looking at these coefficients. And you see, this is the first equation where I have numbers in all of these places. There's no coefficient of 1 anywhere. I don't have 1y, I don't have 1x. It's 3, 6, 2, 3, which means I would not recommend substitution for this problem. You could try and rearrange it, but it's going to be a bit tricky. And so it's definitely preferable to then use elimination. Now, in this case, the elimination is not too hard because I'm noticing that if I take this first equation here and multiply everything by 2, then this first term will become 6x. Then I'll be able to go ahead and do a subtraction to eliminate. So looking on at the next problem. So again, here, looking at the coefficients. In this case, sadly, we do not have any 1s. There's no 1x or 1y, so therefore I would not recommend the substitution. We're going to then look at elimination. And then in this case, I'm also disappointed again because there's nothing I can times 2 to get 3. And there's also nothing we can times 4 by to get 5. And so what that means is you're going to have to scale up both equations. So for instance, you could take the top one and multiply by 3. You could take the bottom one and multiply by 2, in which case this here will become 6x, this here will become 6x, and then you can go ahead and use the elimination method. So in conclusion, anywhere that you see y, or x lonely by themselves and they don't have a coefficient in front, so they're just 1, then substitution is a good method, a good option for you. In other cases, I would recommend to choose elimination. If you do have a really strong preference for substitution and you see, for instance, this last question here, and you want to go ahead and use substitution regardless, it is still possible. So for instance, on this one here, we could take the 5y over the other side. So you'll have 2x is equal to 11 plus 5y. Then you're going to have to divide everything through by 2. So x is 11 plus 5y all over 2. Now you have x as being the subject. You can go ahead and substitute that in here in place of x and solve. It will still work. However, as you can see, you get a fraction here, and so you're making the algebra a little bit hard for yourself. Okay, thank you very much for taking the time to watch. I have made 2 videos on how you follow through with the substitution and the elimination method, which I will link in the description for you.